Balloons always fascinate children, but balloons may burst when placed near a hot object. Good day, grade 10! Today, we are going to be fascinated by how the volume inside the balloon gets affected by the temperature. Here are the learning objectives. At the end of the discussion, participants are expected to explain the effect of changes in volume and temperature. Use the volume-temperature relationship to determine the new volume or temperature of a given amount of gas at a constant pressure. Perform calculations involving the relationship among volume and temperature, and cite practical applications of Charle's law. More than 100 years later, after Boyle's experiment about the volume-pressure relationship, French physicist Jacques-Alexandre César Charles performed an experiment in a balloon, hot water and cold water. He used fire to inflate a spherical balloon about 30 feet in diameter that traveled about 1.5 miles before coming back to Earth. In his observation, he discovered the relationship between the volume and the temperature of gases at constant pressure. He found out that various gases expanded by the same amount when heated through the same temperature interval. He then proposed the Charles law, which says that the Kelvin temperature and the volume of a gas are directly related when there is no change in pressure of a gas. So this is a plot of volume versus temperature. When the plot of volume versus temperature for a gas is extrapolated, you will get negative 273 degrees Celsius. When volume becomes zero, it is called absolute zero. The temperature at which the volume of a gas becomes zero when the plot of the volume versus temperature for a gas is extrapolated. An increase in temperature at constant pressure results in an increase in volume. Hot air balloons are perfect examples of the everyday application of gas. As the air in the balloon is heated by a small flame, the balloon expands, making it less dense than the surrounding cool air. Thus, the balloon rises. When a fixed mass of a gas is heated at a given pressure, the volume increases because molecules move faster and expand. This figure explains the relationship between the temperature and the volume in connection with the Charles law. As the temperature of a gas increases, the volume increases. Charles found out that the volume of the gas is directly proportional to its absolute temperature under constant pressure. And it can be mathematically expressed as V is directly proportional to T, or V over T is equal to constant. In comparing the same substance at the same pressure under different sets of conditions, the law can be expressed as V sub 1 over T sub 1 is equal to V sub 2 over T sub 2. Or V sub 1 times T sub 2 is equal to V sub 2 times T sub 1, where V sub 1 is the initial volume, T sub 1 is the initial temperature, V sub 2 is the final volume, and T sub 2 is the final temperature. Since V sub 1 times T sub 2 is equal to V sub 2 times T sub 1, we can derive the following formula. In looking for the initial volume, we use the formula V sub 1 is equal to V sub 2 times T sub 1 all over T sub 2. To look for the final volume, we use the formula V sub 2 is equal to V sub 1 times T sub 2 all over T sub 1. To solve for the initial temperature, we use the formula T sub 1 is equal to V sub 1 times T sub 2 all over V sub 2. And to solve for the final temperature, we use the formula T sub 2 is equal to V sub 2 times T sub 1 all over V sub 1. Since we already know the different formula that we can use, let us apply Charle's law in the following situations or problem. Sample problem number 1. A balloon is inflated to a volume of 2.50 liters in a warm living room, which has a temperature of 24 degrees Celsius. It is then taken outside on a very cold winter day, which has a temperature of negative 25 degrees Celsius. What will be the volume of the balloon outdoors when the amount and pressure remain constant? So these are the given. We have T sub 1 is equal to 24 degrees Celsius. V sub 1 is equal to 2.5 liters. T sub 2 is equal to negative 25 degrees Celsius. And we're looking for the final volume. Since the given temperature is in degrees Celsius, it must be converted into Kelvin. And to do that, we use the formula Kelvin is equal to degrees Celsius plus 273.15. So, 24 degrees Celsius plus 273.15 is equal to 297.15 Kelvin. So this is equal to 297.15 Kelvin. Negative 25 degrees Celsius plus 273.15 is equal to 248.15 Kelvin. So this is equal to 248.15 Kelvin. Since we're looking for the final volume, we use the formula V sub 2 is equal to V sub 1 times T sub 2 all over T sub 1. So this is equivalent to 2.50 liters times 248.15 Kelvin all over 297.15 Kelvin. We are going to cancel the unit Kelvin. We multiply 2.50 to 248.15 and divide the answer by 297.15. And the answer is 2.09 liters. Our final volume is 2.09 liters. Sample problem number 2. A gas at 25 degrees Celsius and 0.987 atmosphere pressure is confined in a cylinder by a piston. When the cylinder is heated, the gas volume expands from 0.250 liters to 1.65 liters. What is the new temperature of the gas, assuming the pressure remains constant? So these are the given. T sub 1 is equal to 25 degrees Celsius, that is equivalent to 298.15 Kelvin. V sub 2 is equal to 1.65 liters. And V sub 1 is equal to 0.250 liters. And we're looking for the final temperature. Since we're looking for the final temperature, we're going to use the formula T sub 2 is equal to V sub 2 times T sub 1 all over V sub 1. And that is 1.65 liters times 298.15 Kelvin all over 0.250 liters. So we're going to cancel the unit liter. And we are going to multiply 1.65 to 298.15 and divide the answer by 0.250 liters. So the answer is 1967.79 Kelvin. So our final temperature is 1967.79 Kelvin. Charles' law explains the following phenomena or applications. Rising smoke. Smoke is less dense than the surrounding air, hence it rises. Heat from the flame causes smoke particles to move rapidly, increasing the volume it occupies, thus lowering its density. Swelling rubber. Slightly inflated rubber life raft slightly swells when left under the sun. Heat from the sun causes the gas molecules to move rapidly and farther apart from each other. An inflated balloon shrinks when placed inside the refrigerator. During cold weather, tires become flat because the air inside the tires shrink. Thank you for listening, Batang IS! I hope you all learned something from this video. If you have questions or clarifications, just drop your comment or message me through Schoology. Shout out to Ma'am Lace, Sir Bryce, Ma'am MM, and Ma'am Rose. God bless!